Good day, guys. You are welcome back to ID International Academic Mathematics class. I want to believe you enjoyed the last class. Today is going to be enjoyable as well. I want to ask, did you lay your hand on the assignment given to you? Okay, let's see the solution together, how it goes. The number one question in the assignment is, find the sum and product of roots of the quadratic equation 2x squared minus 7x plus 3 equals 0. How do we do that? Don't forget, sum of roots is equal to minus b over a. I have taught you how we derive this, and even if you forget the derivation, don't forget the formula. But you shouldn't forget either of them. Minus b over a, your b here is minus 7. So you have minus into minus 7 divided by a. A in that equation is 2. You have 2. Answer is 7 over 2 or 3.5. That is the sum. It's as simple and straightforward as anything. So instead of applying or working in the process of a novice, what is the process of a novice? A novice will go and solve this quadratic equation first. A novice will derive the two roots to the quadratic equation and add them together to get this 3.5. And actually, it's going to get the same answer, but it's going to spend more time. So don't be a novice. Product of roots is c over a. C in the equation is 3. Y a is 2. So your answer could be 3 over 2 or 1.5. That is that about question number 1. Let's move on to question number 2. Here is question number 2 of the assignment, which reads, find the quadratic equation whose sum and product of roots are respectively 1 and minus 6. In this case, you have been given the sum of the roots to be 1. You have been given the product of the roots to be minus 6. And you have to find the quadratic equation whose sum and product of roots are given here. So this is what you do. Remember, I taught you a quadratic standard where we write x squared minus sum of roots into x plus product of roots equals 0. This is the quadratic standard that you are expected to use in this regard. And how do you use it? Just substitute the sum and products given to you into this standard. You have x squared minus, what is the sum of roots given here? That's just 1 into x plus the product given to you here is minus 6 equals 0. So you have x squared minus x minus 1 times x is minus x. Plus times minus here is minus. So you have minus 6 equal to 0. The quadratic equation whose sum and product of roots are respectively 1 and minus 6 is x squared minus x minus 6 equal to 0. Do you understand? Good. Here is question 3 in the assignment. If 1 is a root of x squared minus 3x plus b equals 0, find a, the value of b, b, the other root. You know we have two roots to every quadratic equation. And one of the two roots has been given to us here to be 1. We are to find the other root. Then there is an omission in the equation. There is something that is not known perfectly in the equation. B, the value of b is not known. We have to find the value as well. So how do we go about it? Don't forget, the real variable of every quadratic equation, the variable that carries power 2, degree 2 in the quadratic equation, that makes us to call it quadratic, that variable is always equivalent to the root of the equation. Don't forget, at the end of every quadratic equation, we conclude, if we are using y as the variable, we conclude y equals 3 or 5. If it is p equals minus 2 or 1. You can see that we conclude that the variable is exactly equal to the root of the quadratic. Therefore, in this case, the variable used in this equation is variable x. And we have been given one of the two roots of the quadratic equation to be 1. Meaning that that variable s, given that we are using here, is exactly equal to 1. So you will write, to answer question A, since x is equal to 1, the variable is equal to the root. Therefore, substituting 1 for x will be the next thing there. You have 1 all square in place of the equation, minus 3 into 1 plus b equals 0. So 1 square is 1, minus 3 times 1 is minus 3, plus b equals 0. 1 minus 3 gives minus 2. Minus 2 plus b equals 0. Collecting the like terms, negative 2 is a figure. 0 is a figure. B is an algebraic term. It's a variable, so collect the like terms by leaving the b here and transferring the negative 2 to the other hand to meet this 0, and the negative becomes positive. You have 0 plus 2, which gives 2. So the quadratic equation given to us is therefore x squared minus 3x plus 2 equals 0. You can now see the real picture of the quadratic equation given to you. So by this you have answered question A, the value of b, which is 2. What next? We are to find the other root. In this, you have different methods to find the other root. You can decide to solve this equation using any method, using factorization method, or completing the square method, or quadratic general method. You can use any of them to solve this quadratic equation to derive two roots. But definitely, one of the two roots you are going to derive will have been 1, and that have been foretold right from the beginning. The other one that is not 1 is the other root you are asked to find. That is it. But there are more easier ways to find that. Number 1, you can use sum of the roots method to find the other root. And also you can use product of the roots method to find the other root. Take for instance, let me use product of the roots method to find the other root. I will just write, let x, always use the variable that has been used in the equation, use it. Easier right. So let x be the other root. So if that is the case, you now want to use products. Product is equal to c over a. That is product of the roots. And the product means multiplication of two roots, literally. And you have said, let x be the other root. And 1 has been given to you as one of the two roots. So you now have product of the two roots will be, in place of this product, see 1 times x equals, instead of writing c over a now, what is your c in this equation? Your c is 2. What is your a? Your a is positive 1. So 1 times x is x. Is equal to 2 divided by 1 is 2. So the other root is 2. That's it. Therefore, the other root is 2. That is it. And if you go ahead, instead of using product, if you use sum, you are going to get exactly the same thing. So I want to believe I've clarified this. Can we continue? Good. Let's move on to the last question in the assignment. Question number 4, which reads, if alpha and beta had the roots of quadratic equation 6x squared minus 3x minus 4 equals 0, find A, alpha plus beta, that is sum. B, alpha beta, that's product. C, alpha over beta plus beta over alpha. How do we go about this? Number A, alpha plus beta is sum of the roots, which means minus b over a, which is minus into, what is your b here? The b here is minus 3. Here is 6. And finally, minus times minus is plus. So we have plus 3 over 6. 3 divided by 6 is half. That is the sum. Hence that b, alpha beta is product. You can see that the two roots, if we assume that alpha and beta are the roots of the quadratic equation, that means multiplication of the two of them is product. So product is c over a. Don't forget, c in this equation is minus 4, a is 6. Reducing minus 4 over 6 to the lowest term, so you have minus 2 over 3. 2 goes in 4, 2 times. 2 goes in 6, 3 times. So you have minus 2 over 3 as the answer. Question C, that is alpha over beta plus beta over alpha. What you do here is take the LCM. LCM here is alpha beta. Beta in alpha beta gives alpha. Alpha times alpha, that is alpha square. Plus alpha in alpha beta gives beta. Beta times beta is beta square. Don't forget, I told you in one of the previous classes that sum of two squares can be expressed in another way. This sum of two squares can be expressed as alpha plus beta all raised to power 2 minus 2 alpha beta. The sum of two squares, alpha square plus beta square, can be expressed thus: all over alpha beta. So don't forget, alpha plus beta in this bracket means sum, and in A, sum is half. So substitute half raised to power 2 minus 2 into alpha beta here, which is the product, is minus 2 over 3. Put it here, minus 2 over 3, all over minus 2 over 3. 1 over 2 square is 1 over 4. Minus 2 times minus 2 over 3 is positive 4 over 3. Do you understand? I bracket them together for easy operation. Instead of this division line, I write divided by minus 2 over 3. This division symbol is the same thing as this division line here. So the LCM in this is 12. 4 in 12 is 3. 3 times 1, 3, plus 3 in 12 is 4. 4 times 4 is 16. In place of this division sign, put multiplication sign, and the divisor minus 2 over 3 turns upside down to become minus 3 over 2. 3 plus 16 is 19. So 19 over 12 times minus 3 over 2. 3 in minus 3 gives minus 1. 3 in 12 gives 4. So minus 1 times 19 gives minus 19 all over 4 times 2, that's 8. Minus 19 over 8 is the answer. Or we write minus 8 in 19, that is 2. 8 times 2 is 16. Subtract 16 from 19. What do you have? You have 3. You have 3 over 8. That is the end of all the assignments. Do you understand? Good. Now, having done justice to the assignments given to you in the last class, today we are moving straight to another topic called indices. That is what we want to deal with today. What do we mean by indices? Indices means powers or exponents. In fact, indices is a plural word. Its singular form is index. Index means power or exponent. So when you hear or you see indices, you know it is plural. It just simply means powers or exponents. So we want to see how we can express numbers in index form. What do you mean by numbers in index form? We want to see it. If you have x raised to power a, x is the root number. A is the index. The x here is the root number or base number. So, how do we now express numbers in these formats? That is what we want to learn now. Number 1, 2 is a number. To express it in index form, we write 2 raised to power 1. 3 is a number. To express it in index form, we write 3 raised to power 1. 4 is a number. To express it in index form, we write 2 raised to power 2. Also, 8. To express it in index form, we write it as 2 raised to power 3. Some numbers, like 64, can be raised in index form using different base number. Like this 64 could be raised as 2 raised to power 6 is 64. Also, you can raise it as 4 raised to power 3. And finally, it could be 8 raised to power 2. In any case, we are raising 64 in index form. What of 243? 243. It is raised in 3 raised to power 5. Is 243. So numbers in this format are referred to as index number. Numbers in index form. Do we all understand? Good. We have seen how to express whole numbers in index form. Let's see how to express fractions in index form. So we deal with expressing fractions in index form. So to express fraction in index form, I mean, if you have something like 1 over x, something like 1 over x squared, how do you express this perfectly in index form? 1 over x will be expressed as x raised to power minus 1 to make it be in index form. And also 1 over x squared. This is partly in index form. This is just a semi-index number, 1 over x squared. So we have to make it totally in index form. So we express 1 over x squared as x raised to the power minus 2. X raised to the power minus 2. So studying the format is enough for you to understand what we do here. 1 over x becomes x raised to the power minus 1. 1 over x raised to the power 2 becomes x raised to the power minus 2. Now, let's see what to do if you are to express 1 over 2 in index form. 1 over 2 in index form will be 2 raised to the power minus 1. It's as simple as that. Also, 1 over 4 in index form will be, you first express this as 1 over 2 raised to the power 2, so that it will be like 1 over x squared. Am I communicating? So after that, you express it finally as 2 raised to the power minus 2. I hope you are following. So 1 over 9 also will be expressed first as 1 over 3 squared. And thereafter, remember this, you write it as 3 raised to the power minus 2. It is interesting. So what if you are given a number like 2 over 162? What will you do? You see that 2 cannot be, raised. If you raise 2 in index form, it will be 2 raised to the power 1. And 162 cannot be raised just like that, straightforward. Therefore, when you see a number like this, simplify the number first. Write the number in the simplest form possible. So this will be 2 in 2 will give 1. 2 in 16, 8. In 2, 1. So, in short, 2 in 162 is 81. To now express 1 over 81 in index form will not be a problem. You just first express it as 1 over 3 raised to the power 4. And finally, 3 raised to the power minus 4. So it follows the same pattern with this. So what if you are given 1 over 25? What will happen? You express it as 1 over 5 squared, which is 5 raised to the power minus 2. Let's try 1 over 32. What will this be? This will be 1 over 2 raised to the power 5. And finally, 2 raised to the power minus 5. You must be very fast at breaking numbers into factors. And you write the numbers as a product of its factors. So that one will help you in this regard. So this is how we express numbers, especially fractional numbers, in index form. Let's move on to the next level here.